So this is the introductory lecture of beam analysis. Here we will get to know about the basics of internal forces along with different loadings and support conditions. In addition to that, we will also learn to implement the equilibrium conditions to analyze a beam. When a beam is being loaded externally, internal forces develops along this beam. These internal forces have two components mainly, starting with the shear force or the internal shear forces. It's acting parallel to the cross section, and the normal forces acts perpendicular to the cross section. These normal forces might be of two types. We can see here that some of the normal forces are acting towards the beam. It compresses the beam, so this normal force will be known as compressive force. On the other hand, some of the normal forces are acting away from the beam, which are known as tensile force. In a particular cross section, in order to carry out this equilibrium state, these two forces, which is tensile and compressive, remains equal but opposite in direction, so that no net normal forces can develop. They do combinedly produces a moment, which in yellow color we can see here. So it means we can represent this overall internal forces acting on this type of structural member with two of these. One is shear force acting parallel to the cross section, and another one is bending moment, which produces due to the tensile force and compressive force. So in order to determine the total impact or maximum internal forces acting on a structural element, we need to determine the shear force and bending moment. Now we can see here the different types of loadings, starting with the concentrated load or the point load. Second one is uniformly distributed load, and the third one is moment. So these three types of loadings we will see mainly. We know that this type of loadings will destabilize our beam. This type of loadings will destabilize our beam or our structural element. So we need to provide restrictions against these loads, or we need to provide supports so that it can carry these loads. We can see here the example of supports. There are three types of supports mainly, starting with the pinned support. The second one is roller support, and the third one is fixed support. The pin support provides restrictions in horizontal and vertical direction of moving, but allows the rotation, or it does not provide restriction against moment. On the other hand, roller support prevents the beam moving in vertical direction, but it allows horizontal displacements and rotation. So this support has single reaction. Finally, the fixed support prevents all displacements and rotation. So we can say that the fixed support provides restriction against horizontal movement, against vertical movement, and against rotation. So it will have three reactions. So as we have said, the pin support will be having two reactions, and it restricts the beam in two directional movements. On the other hand, the roller support restricts the beam in vertical movements, so it will have one reaction, and the final one, which is fixed support, will be having three reactions in total. First common step is to draw a free body diagram of the beam. It means to incorporate reactions in place of supports. We have seen that there were a pin support and a roller support, but in place of pin support we have provided here two reactions, and in place of roller support we have provided one reaction. The second step is to determine reaction forces and reaction moments at beam supports. This is the second common step between the methods. So in order to determine this reaction, which is the second step, we need to use the three equations of equilibrium condition. Equilibrium condition has three equations, which are summation of f of x equals to 0, summation of f of y is equals to 0, and summation of moment is equals to 0. Here's the summation of f of x means summation of all horizontal forces will be 0, and summation of f of y means summation of all vertical forces will be 0, and the summation of moment will be 0. We have three equilibrium equations, but we know that using these three equilibrium equations we can determine three unknowns at max. So maximum three unknown reaction can be determined using these general equations of equilibrium, these three equations. Our provided beam has three unknown reactions. That means this beam is statically determinate beam. On the other hand, the second beam, which is shown here, there are 1, 2, 3, 4 number of unknown reactions which are in yellow colors. But we know that using equilibrium condition we will be able to determine three unknown reactions at max. So we will not be able to determine all the reactions of second beam. So this beam will be known as a statically indeterminate beam. In general cases, we can say that a beam having unknown reactions greater than 3 will be called as indeterminate, and the beam having unknown reactions less than 3 or equals to 3 will be known as statically determinate beam or a statically determinate structure. In your exams, you may find a question like write down the differences between statically determinate and statically indeterminate structures. So here are the differences.